So the last thing I want to show you with this demo is how to make an object play a sound when it collides with another object. And this will help give all of our objects that are bouncing around more of a sense of being grounded and actually physical. So to start with, I still have this other thing on my ball. I'll hit play, we can hear it. Changing the pitch based on how fast it's moving. It's pretty fun. We're going to add some new stuff to our cube. So now our cube will make a sound when it runs into other objects. So to start with, I'll add an audio source again. So this will play sounds for us. And I won't make it play on awake, and I won't even assign anything to this audio clip. I can just leave all this empty because I'll control it all with code in a second. And then I'll just go ahead and add a component, make a new script. We'll call it play sound on collide, say. I'll hit create and add. I'll think about it for a second. Now I can double click and go in here and start editing our script. So just like with our pitch control script, I'll want to get reference to the audio source that we'll be using. So I'll say audio source a source, and I'll just call it a source like that. And start, I'll get the reference, a source equals get component audio source. And then in this case, I'm not even going to use our update function. There's another function that I want to use called onCollisionEnter. So just like any of these other kinds of components, there's a lot of different functions. So audio source has a bunch of functions and properties. Our rigid bodies have functions and properties. Well, so do our custom scripts, which are actually a component called a mono behavior. And that's kind of the basis of every component in Unity is basically a kind of mono behavior. So I can go and look at this past video. No, I can look at the reference and I'll search for mono behavior, which is spelled the British way with the U in it, I believe. And I'll search for a moment. Yep. Okay. So, description. Mono behavior is the base class from which every Unity script derives. You must explicitly derive from whatever. But so we can look and see what all of the messages are, and also the public methods and everything. So these are different functions that we can use, just like update and start, which happen at different times. So awake is called when the script instance is being loaded. Fixed update, frame rate independent mono behavior.fixed update, blah, 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 blah. This is fixed update is kind of like update, but it works on the physics update step and not on the graphics update step. We can have a function that's called when the application quits or pauses. But what we're interested in is this one, onCollisionEnter. It's called when this collider or rigid body has begun touching another rigid body or collider. I click on that and get a little example code here. So that's just to say, if you're curious about how to do something, on mouse enter, on mouse exit, on mouse drag, on trigger enter, there's all kinds of these messages that you can use in your scripts to cause things to happen at different times. So I'll get rid of update because I don't need it. I'll just start typing void onCollisionEnter. And when I hit enter, you can see Visual Studio auto-completes this whole thing for me, and it formats it correctly. This is really the benefit of using something like Visual Studio to work on your code rather than, you could conceivably type all your C# code in Notepad or something, but you wouldn't have these nice features. Okay. This looks a little different than start. We have this keyword, private, Anything that doesn't have the word public in front of it is actually private by default. And what the difference is between a public variable or function and a private one is public variables can be accessed by other scripts or even the Unity editor. So if I made this audio source public, I could change it in the editor. If I made this public, then I could just have another script that gets a reference to this one and calls this function. I don't really want that, so I'll just leave this as private. And again, they're private by default, so if you don't see that private thing in front of it or public, it just means it's private. It also looks different in another way, though. Start doesn't have anything inside of these parentheses. OnCollisionEnter does. It has a variable called collision, which is of the type collision. You can see when I mouse over it, it tells me describes a collision. Very helpful. So this contains information about the collision that we just had happen, which we'll use in a little bit. But so when we have functions, we can pass in variables to them inside these parentheses. Anyway, don't worry about all that for now. For now, I want to play a sound when we enter a collision. So I'll start by creating a public audio clip, which will be our sound. I'll just call it clip. And inside here, I'll say a source dot play one shot. And this is a function, and I'll say clip. So this is telling the audio source to play this clip one time, and that's it. So I'll hit save, Control S, Command S if you're on a Mac, and then I'll just tab into Unity. And you can see it'll update this script in a second. So now it has this this field here where I can add an audio clip. It shows me that, again, because this variable is marked as public. I could do that with this audio source too. And then I could set the audio source here. I didn't do that though because I'm getting that reference here. But okay, so now I can just place the sound I want here. So I'll go into my files here and find the TomTom sound, or I can just I can find the sound I want by clicking on this dot as well. And this will show me all the sound effects in my entire project. I could search, but there's only two, so I'll just click TomTom, which is kind of a drum sound. And when I hit play, now that thing falls and does its thing. Our cube is kind of floating, so I'll just chuck it down. Oops, throw it down, and now you can hear it. And I'll even just turn on gravity for this cube, so it'll. There we go. So that's great, but we want this sound to change based on change volume based on how hard the cube hits the ground. And that information is stored inside this collision object, like we said earlier. So I'll get the volume out of it. I'll say float volume equals collision dot, let's see, it has all these different properties here, which I can just look through. So there's collider, there's contact count, which is how many points of contact were between the two colliders. There's tons of these things, but the one that I want is this one called relative velocity. So this is the relative linear velocity of the two colliding objects. Basically, how hard did they hit each other, and at what direction did they hit each other? So I'll get relative velocity, and I'm actually only really interested in the speed or the magnitude of our relative velocity. So I'll say dot magnitude. Now there's actually two versions of this play one shot function. There's one which just takes an audio clip, and there's another that takes an audio clip and a floating point number, which is the volume scale. So that's the volume. So I will set that to be volume and then hit enter. So now this should change how loud our clip is played based on the relative velocity of our collision. So I'll hit play. We'll see what that looks like here. That was really hard. Okay, so that's kind of going way more than the maximum volume, which is why it sounds really bad. So I'll multiply that by some number like 0.1f to kind of reduce it. That's more reasonable. So hit very soft, throw it harder. Whoa. Still is going over kind of a maximum volume, which is why it's so bad when I do that. So I can even clamp this value so it never goes more than 1. Because our speed can be way higher than 1. So I'll say volume equals mathf.clamp. And so this mathf has a bunch of different functions we can use for math stuff. So I can clamp my value from of volume. The minimum will be 0, and the maximum will be 1. So now volume will never be greater than 1 or less than 0. I can probably get rid of this for now. So that never sounds broken. And then if I just kind of gently. I think I'll want to just modify this a little tiny bit. So I'll reduce, this is basically cutting off the top of our maximum volume. So I'll just do this. I'll multiply this by 0.1f. So we get a little bit more dynamic range there. So now it's all soft when it, and then so there you go. And you can see our cube feels a little bit more. All right, and that's it.